TikTok. They're gonna keep trying to ban me. Winnie the Pooh. Just say Winnie the Pooh. Okay. E, Q, EU, E to AU to whoops. Just set the E to... Fembox, I can't understand what's going on there. Okay. Let's go see what we got on the queue. Already 5 questions. Wow. Yes. I will say, try to have you guys submit like I would say no earlier than at like 30 minutes before the stream starts. Like, otherwise you get so many votes. It's kind of hard to like compete. Trying to say just set the queue to auto empty 10 minutes before stream. I could do that. Yeah, I could do that. And that would be kind of like a warning to be like, yeah, no. I just don't even want like students, I guess. Well, I'll come up with something. Like anything, we always have to adapt to the situations and like users. And I know this is something Zach was probably dealing with the stream this morning. Like UX and UI is so important. Just even things that you think are straightforward and obvious and very like, oh yeah, that's how I should use it, isn't necessarily straightforward to other people. Yeah. You only have to do one of those? Okay, cool. All right. So, if if you get picked, I'll select one of yours, I guess, or something. Yeah. Okay, cool. All right. Well, here, let's spin the wheel, see whose question we're gonna go do first.
Let's go gambling!
It's one of yours, JSnap. Okay, cool. So then I will clear your other one, or I'll still put it in the Discord, JSnap. I'll still put it there, but I'll remove it from the queue so it's not occupying. There you go. So now the chances are looking a little bit better. All right, what do we got? Oh no. What is this? Analyze the op-amp circuit. Oh man, I haven't done op-amp circuits in forever. There's always these like equations. It's like VTH, VCC, V this, V whatever. Yeah. Yay, pianos. Is this a piano, Femvox? Femvox actually knows a decent amount about. I think Femvox was an electrical engineer, or is an electrical engineer. Op amps are called. Oh, is a piano an op amp? Oh, that was autocorrect. Okay, got it. Nice. Oh, I need to open up the right version of my soundboard. This is not the right version of my soundboard. Is it? Oh, it is. Okay, never mind. All right. I don't know what this is. What is this? Is this like an LED? You can turn off autocorrect. I think you can. The example problems I've solved aren't close to this, so I'm lost to it. I mean, I'm lost too. Analyze the ideal op-amp circuit to find an expression for V0, okay, in terms of VA, VB, and the resistance values. And then I guess this is the op-amp. You have 2 sources here, Femvox, and they're coming in parallel into here. And then there's this. I mean, I have no clue what this is. What? To the AI we go. What do they want? Analyze the ideal op-amp. This is more this is electrical engineering, which you don't really get into in physics. You don't get into the specifics of like transistors. For ideal op-amps, the input currents are 0. So at the non-inverting input, the node voltages do what? What is the non-inverting input? Non-inverting. No voltage drop between op-amp inputs. Okay. The voltage at the plus input. So V plus minus VA over RA. Oh, okay. No node voltage is only set by VA through RA and RB. Okay. So you want the currents to be 0. Interesting. Okay. I don't know why, but this is just a thing, I guess. All right. So if you want current here to be 0, that means the current from here has to cancel out the current from there, right? Which, wait a minute. How are... oh, okay. So... if the currents are opposing each other, maybe. So V plus equals V minus. Oh, wait. V plus equals V minus. But here, they're solving... they're saying the voltage at the plus input, this all has to be equal to 0. Yes, A. Submit a question if you want. There's a website, actualofficehours.com. Just go to that website, drop a screenshot. What's going on here? I see how this is kind of current. I guess if there is a voltage here, and then there's a voltage here, that the difference in the voltage divided by the resistance there would get you the current through there. But then you also have this one coming up as well. Yeah. Yeah, honestly, yeah, sorry, Jason. I don't know how to do these. These are, I don't do op amps, so. I will put them in my Discord, though, if someone else wants to, like, take an attempt at them. Otherwise, yeah, I'm not sure I can really help with these. I've never done this. And nor do I have the time right now to learn how to do it, so. Not so fun fact I learned today. Adult circumcision repair can be really expensive. Excuse me, what?
You're not that guy, pal. Trust me.
Excuse
You're not that
me?
guy.
What? Oh, dear. Spare me the details, I guess. But yeah, anything medical is really expensive as you get older. I don't even want to know like how that specific topic comes up, but I feel for you. Okay, let's go spin another question. Hopefully I get something I know how to solve.
Let's go gambling!
Somehow not... oh, it's Tuma. Look at that, Tuma. You had a 6.2% chance. There we go. Interval of convergence. This I can solve. We love this. What's up, Tooms?
Oh my god, what are the odds of that?
I mean, it was 6%. It was like 6 in 100, so yeah.
That's insane.
Oh, you saw an advert on Facebook earlier. I don't know why Facebook is advertising to you that type of repair surgery, but I don't know. I've been getting some weird ads too. Okay,
Hates Jews confirmed.
What confused? What confirmed?
Facebook hates Jews confirmed.
Oh yeah, there you go. Facebook is anti-Semitic. I wonder if I'm gonna get violated for saying anti-Semitic. Am I even allowed to say that word? I can't fucking tell anymore.
The term isn't even like
Right.
proper these days.
I know, but TikTok is just so strict on their moderation. Like anything, they just start flagging. It's super annoying.
Oh my god, I got banned on Instagram.
Oh dear.
No.
That's not difficult.
That's not difficult.
Oh no.
Oh no, you showed an ankle.
Can't do
The
that.
fuck is this Victoria time?
Haram. Okay, let's see. Okay, interval of convergence. So this is figuring out like what values of x cause this series to converge. So this is an infinite series, right? See how it goes up to infinity?
I'm not too familiar with power series. I just got done studying Taylor approximation, polynomials.
Yeah, a Taylor
approximation.
series.
Yeah.
Okay. Yeah, so, I mean, these are infinite series, and then this is a type of infinite series, which is called specifically a power series. The
Right.
reason is you're having something that's getting raised to a power. It's a geometric series, not a power series, is it? Jeff? No, I think it's a power series. You got like to the end, no? Jeff says it's both geometric and power.
Oh no.
Jeff, you're gonna lose some
Yeah,
more
I was gonna
years.
say, I think it is a power, or not a power, geometric.
I think this makes it geometric if n was constant, but n is also increasing, so that makes it power. Yeah. Here's what people are talking about. They're saying if you had like I don't know, like 1/2 to the x versus
That'd be like geometric.
this would be a power series. But then if you
Oh.
had x to the 1/2, then this would be geometric. I think.
Huh.
Anyways. Okay.
I'm not sure what power series is though.
Okay. Yeah. Power series is just a type of series. In this case, where things are getting raised to a power. So if you ever wanted to write out the first couple terms of this, do you see how the first term would be x over 8 to the 0?
Uh-huh.
And then this summation thing means you then bump n up by 1 and then write out the next thing.
Yeah.
And so this
That's
would be
right.
x over 8 to the 1 plus x over 8.
To the third and the fourth and so on.
No, to the 2. Yeah, exactly. It goes on forever, right? Yeah. Now,
Yeah.
what makes this interesting is this series is a function of x, okay? So you're allowed to put in different values of x, and you would get different values for this infinite series. A lot of times, infinite series only have one variable, and it's the index variable. So a lot of times, an infinite series would look something like this. It'd be like n equals 0 to infinity, and it would be like 1/2 to the n. You see how there's no x in here, right? Yeah.
Yeah,
And, you've probably seen this in. Have you done Maclaurin series yet?
yeah. When you just put the 0, that's your origin, right?
Exactly. So it's a Taylor series centered around the origin. But these are ways to write. Here, do they have? Yeah, they got the notation of them. Can I get this in a bigger image, please? Where is it? Where was that thing? There we go.
From what I understand, these are just to like approximate and like basically match the function.
Yeah. So you're taking a function that is not a simple polynomial, right? Like e to the x is a special function, cosine is a trig function, 1 over 1 minus x is something weird and rational. So what you're doing is you're saying I can write this as polynomials, which are just different coefficients slapped on top of like an x to the second, x to the fourth, x to the whatever. And the reason is that these are a lot easier to deal with in doing algebra stuff, especially when you want to approximate something. So, for instance, if you were trying to approximate 1 over 1 minus x, well, this one isn't too bad to do in your head. Let's say you were trying to approximate e to the x. You can't do that in your head, right? You don't know what e squared is. You don't know what like e to the fourth is, right?
Yeah.
That doesn't compute. But what you could do is, let's say, for instance, that x is sufficiently smaller than 1. Let's say, for instance, example, x is equal to 1/2, okay?
Yeah.
And I ask you, what is e to the 1/2, which is the same thing as asking, what is the square root of e? Again, something you can't do in your head. But if you understand that, 1/2 is decently close to 0, so it's not the worst thing in the world to use a Maclaurin expansion. Maclaurin expansions only work when you're looking at values of x here that are close to 0. 1/2 is whatever, it's close enough. You can use this to approximate the square root of e. And
How
you could
close
just keep...
does it have to be?
Exactly. Okay, so that depends on your personal preference for how close you need it to be. You know, if you're designing a massive boat and I don't know, you just need to make sure it doesn't sink, like you probably don't need to be that exact. But if you're designing a spaceship and it needs to hit like an exact orbit and it can't, you know, fuck up, that's when you need like a lot more precision. And the way you can tell what your precision is also called like the error bound on a Taylor series. Like, did you do that?
Error bound, I recall that.
Yeah. The error bound is like, in simple terms, the error bound. So let's say, for instance, I just went up to like this term in calculating e to the 1/2. The error bound, which is like the maximum amount of wiggle, maximum amount of error I can be off by, is usually the next term. So wherever I stop, the next term is how much plus or minus error there could be. Kind of what I say. Yes.
What does that mean though? Like, okay, that's the amount of error, like 1/24 x squared.
Well, yeah. Also, I think this is fucked up. I think this is supposed to be to the 4th. Yeah. I think whoever wrote this diagram screwed up.
Oh no.
People make mistakes. It's okay. But for example, if we wanted to calculate what e to the 1/2 is, right, by using x to the 1/2, you could do it this way, right? That would be 1 plus 1/2 plus 1/2 times 1/2 squared plus 1/6 times 1/2 to the third, and then so forth and so forth. Something you should notice here, though, to get a value. Do you notice how the exponent is like going up, right?
Yeah.
And if this thing is less than 1, what happens when, 1/2 goes like 1/2 to the 5th? What happens to the number? Is it getting bigger or getting smaller?
It's getting smaller.
It's getting smaller, right? This is like 1 over 32, which is, I don't know, like 0.03 or something. So why these series are really powerful is, and you do this a lot in physics, is you say, well, if x is sufficiently small, if the absolute value of it if it's sufficiently close to 0, then I can just start ignoring these higher exponent terms, because I can say, well, if x is small, something small to the 4th is going to be really, really small that I don't even care about it.
Yeah.
Oh, this person wrote it. Yeah, this whole thing is okay. Whatever. There's a lot of mistakes in this, so don't worry about this.
Yeah.
So yes, okay. And the key thing with all these series is that these series converge. What converge means is that as I add up all of the terms here, I will eventually get to cosine of x.
Is the goal here to like get an approximation?
That's one of the uses of this for sure, is to get an approximation for these in terms of polynomials. And then what we end up doing is we'll start like nixing off some terms and being like, oh, I only care about the first 2 terms for like practical purposes. Yeah.
But how do you go from the function to this? Oh wait, I remember that.
Yeah, from this to this, that's an equation. That's a Taylor series centered at 0. Not the worst thing.
You gotta take the derivative, and then you gotta I remember.
Yeah. JHN says, when do you actually cut it off, though, and say, okay, that's 0? It depends how comfortable you are. Again, that is kind of a hand-waving thing, especially in physics, where we'll say, well, for the purpose of, saving paper and not destroying all the trees, let's only consider up to x to the 2nd, or let's only consider 3rd order x to the 3rd. So
is it difficult to go from the series expansion to the sigma notation?
So yes, not difficult, but you have to notice that this looks like a pattern. So what you're noticing here, right, is it's like x to the 0, x to the 1, x to the 2, x to the 3. So that's why the series is going as x to the n, right? Because this is n equals 0, this is n equals 1, this is n equals 2. And then what you're also supposed to notice as a pattern is that the coefficient in front is the same thing as 1 over n factorial.
Oh, that's hard to see.
It is hard to see. At first, yes. Eventually, you'll get good at this, and you'll see patterns. Also, if things are oscillating, you see how this is minus, plus, minus, plus?
It's, yeah.
That means you need some, negative series. 1 to the n. Yeah. So, these are all things you notice. But the key thing with all of these series is that they converge, which means that as I add more and more terms, I eventually get even closer and closer and closer to whatever my original function is. Okay? And it doesn't diverge. So in this case, x over 8 to the n, they're saying, okay, what values of x will this actually converge to something? As I add up infinite numbers, I will finally get to something that is, not going crazy. You can, there are rules and stuff that you're supposed to use for testing convergence of series. This is, I want to say this is called is this the P test? Is the P test? Is that what it is? One sec.
P series?
P series. Yeah, I think it's a P series.
I don't think it's P series.
No, P series is like a 1 over, it's either 1 over P.
It's 1 over n to the P. Yes.
Yeah, I think that's just a ratio test, right? It's the ratio test where R is...
I think it's also just by definition of a geometric series. You just need whatever this thing that's getting multiplied by to always be in between -1 and 1. Yeah, I think it's by definition of a geometric series. Yeah, this is it. Here, one sec. This is one of the rules they come up with. So, and Zach is the expert on this, by the way. I'll shout him out. Zach has written his whole master's thesis, I think, was based on figuring out the best way to teach sequences and series, because this is the one part of calculus that like always screws kids up. Everyone gets totally wrecked by this part of calculus.
Yeah.
Yeah, it blows. It's cool once you know it.
I think shells was harder for me.
Oh yeah, because you have to kind of be
isn't-
visual.
What
do you think,
the
Breskles?
best method that I know to teach geometric series and just series in general
Yeah.
is study like crazy on your first 2 exams in Calc 2, and then you can get a 50 on the third one
God
and
damn
still
it.
pass Calc 2 with a B.
Yeah, that's the you're in the car and you're just hoping that it just scrapes across the finish line somehow. It's like it's on fire and you're just like, okay.
No,
we
it's
made it.
not hoping that it's gonna scrape, you know. It's just because it's
Like pass the
planned.
first
It's not-
test and then
there's
the
no hope if you're confident and you can
Yeah.
get like a high enough score on the first couple ones, then you can skate by on the
Yeah,
third one.
you can
and
just
on
you can
your
take a
final
beating.
it's cumulative, and
Yeah.
then you
The only
just
problem is that like
Surprise, motherfucker.
if you do that and you don't actually learn the later stuff and you want to do like for instance engineering or any sort of like higher level math thing, you really need to know these things. So you're just
I mean, yeah, but I'm not gonna lie. That's kind of what I did on it because I had already taken
Yeah.
Calc 2 and I didn't want to remember all of it, and I
Yeah.
honestly haven't touched any series other than a Fourier series and a Laurent series
sure
since Calc 2
sure.
in any
Yeah.
class ever.
It depends what you do. I remember a lot of you're right. You kind of use more of the basic series in what is it like the hydrogen approximation, perturbation theory, all that. It's not super crazy, but
just try your best, I guess. Whatever.
yeah, try your best.
whatever.
You should try to learn this, but again, don't get upset if it's not making sense. It's one of the harder things. In general, how any of these like series type questions work is they'll give you something and then you're going to perform a test on it. And you need which test you perform depends on what the thing looks like. Okay.
Right.
So this is always like kind of like the most basic test you can do.
Divergence
on-
test. Yeah.
Yeah, it's so what you do is you basically look at the infinity term, or like the n equals infinity term, and you have to make sure that that thing goes to 0. Okay. So
Uh-huh.
looking at this, right, and if you wanted to look at like the infinity term, right, what's like the last term, you can see that there's some restrictions on x, because if x is greater than 8, okay, let's say x is equal to 8, then 8 over 8 is just going to be 1 to the n, and so at n equals infinity, the last term is still 1, which is not 0, which means as a series, you just keep adding 1, and that's not good.
You're not that guy,
It
pal.
won't-
Trust me. You're not that guy.
The series won't ever converge because as you go to more terms, you're going to keep adding more things that keep bumping the number up.
It's so if it's equal to 1, that's bad.
It diverges, yeah.
It says
This is
it's inconclusive, I think, right? Never mind.
no, it's inconclusive if it goes to 0. Yeah, this is one of the dumbest tests, but it sometimes like it's very easy to just look at. If you can automatically rule out that the last term doesn't go to 0, you can say, nice, diverges. I'm done. More often than not, you're trying to prove convergence, and so this test is kind of like useless because
Oh.
most series will go to 0 on the n equals infinity term. If they don't, then
Yeah.
like yeah, okay. So then you go down the list of things. My favorite test is the ratio test, which I guess you could use with this one maybe. But right off the bat, this does look like a geometric series. And so what they tell you is that for a geometric series, this will converge as long as the thing being raised to the power of n is less than 1, or the absolute value is less than 1. So all
The
you have to do,
ratio.
yeah. Well, so in this case, right, this looks like this whole thing right here, this is r. You have the sum from n equals 0 to infinity of r to the n. And this is a classic geometric series.
Yeah.
And in order to converge, this ratio, the absolute value of it, has to be less than 1. Okay.
But how can you tell if there's an X?
Well, good. Okay, so notice how it's just something being raised to the n, and I know that something has to be less than 1. Now I plug back in and I say, oh, well, x over 8, because that's what the r was, right? This whole thing was x over 8. This has to be less than 1.
Mhm.
Okay? So then that puts some restrictions, right? You get x over 8 is less than 1, or x over 8 is greater than -1, I guess. Or negative x over 8. Yeah, I don't know. I forget. Something like this. And. Yeah, not or, sorry. And. Yeah. So x is either less than 8 or it's greater than -8. Sorry, that's how it's supposed to be.
Did you just multiply?
Yeah, I just multiplied the 8. I just multiplied the 8 on both sides.
This is like really weird for me.
Really? Yeah, I mean, maybe it looks
Yeah.
strange. Well, you're just saying that whatever's here has to be less than 1. So 8 doesn't really do much, right? So you could actually just like pull that out, and then you could multiply 8 on both sides. And now you
I
know
haven't
that
done inequalities in like a million years.
I know. Okay, yeah. So this is where like we have to remember what we did in like middle school. Yeah. So the absolute value of x has to be less than 8. And here that this looks like trash, but okay. That means x has to be less than 8 and negative x has to be less than 8. But negative x less than 8 is the same thing if you multiply by -1 as saying x is greater than -8. And so, again, if you want to go back to like middle school and like draw your number line, right? So less than 8, let's say like this is 8, and then the arrow goes that way. And then greater than -8, another circle, this is -8, arrow goes this way. So then the overlap is this. And you would just say like this.
-8.
Yeah.
Or yeah, you could put
Right.
this in the thingy, like the notation, the other notation.
Yeah, you can put an interval
brackets.
notation. You could do this. You want to do this? This is also valid. Yep. Great. Yeah, and so if they ask you that's interval notation. Cool. That's what it is. So you just say this. They said like check the endpoints. Check the endpoints means like what happens if it equals -8. But that doesn't work, because if you were to plug in like actually 8, again, you would get 8 over 8 to the n. And then this is the same thing as the sum as n equals 0 to infinity of 1 to the n. And then this automatically breaks your first rule, which is that as n goes to infinity, I need this term in the sequence to go to 0. And it won't, because it'll just be 1 to the infinity. It'll just be 1.
Oh, wait, so you just plug in back 8?
Mm-hmm.
Because you knew it was 8. It was -8 to 8.
Yeah. So when they say check the endpoints, they want you to check if it's equal to this or if it was equal to this. And then
only
now
the endpoint.
only the endpoints. And now you have a new series, right? Which isn't in terms of x anymore. And then you can evaluate this series based on like one of the rules. We already know that it can't be equal to 8 because of this condition, which is like built into the geometric series. But if your teacher really wants you to like check the endpoints, you would plug it back in actually equaling to 8, and then show that 8 over 8 is 1, and that 1 to the n as a series diverges, because this last term will not go to 0.
Because it's greater than or equal to 1?
Well, no, just think about this. Just like if we were to write this out, right, this would be 1 to the 1, or 1 to the 0 plus 1 to the 1 plus 1 to the 2 plus 1 to the 3.
Oh yeah, because it never like
Right.
increases.
It never decreases. You need these terms to start going down, right?
Uh-huh.
In the case of let's say it was 1, let's say x was equal to 1, so you had the sum from n equals 0 to infinity of 1/8 to the n. See how that's like 1/8 to the 0 plus 1/8 to the first plus
It goes
1/8
down,
to
yeah,
the
it
second.
decreases.
It's decreasing, yeah. So
But why
in
do you
order
need
for
it to decrease?
because as you get further and further down the series, you need to be adding less stuff in order for it to like converge, in order for the sum to be
Oh, so that way it reaches the next
asymptotic.
value.
Exactly. So if you were to think about this as like the sum, and then let's say this is like the n value, right? as you add more terms, you need the amount that's getting added to be like less and less and less, so that eventually the sum will like converge or like asymptotically try to hit some value.
The way they described it for us in Calc 2 is like,
Mhm.
think of walking towards a wall, right? If you're in your room, you walk towards your wall. Say like we're going by 1/2. You can walk halfway to the wall. And then you walk halfway to the wall again, so it's 1/2 plus 1/4 plus 1/8 is another halfway to the wall.
Yeah.
Plus 1/16 is another halfway. And you can keep infinitely adding those small amounts, right? But obviously, one day you've got to get to the wall.
Yeah, you have to hit the wall, please.
But you're never gonna pass the wall if you keep going halfway there, and it's the same idea. But in this case, it's like if you're going 1/8 of whatever your distance to the wall is.
Yeah, that's how
So-
it converges.
Sorry, I have
good.
to be right back. Sorry.
Cool. Okay, I think we solved this one though. I'll let Tim ask more questions afterwards, but cool. Yeah, series are great. Yay! Cool. Good question. All right.
Well done.
Good question, Tuma. I'm doing good, Macho Man. What's going on? X equals -8 is a more interesting endpoint. It is, Jeff, but I think because it is an alternating series, but then the issue is that the terms aren't getting smaller. So, yeah, the summation is like either -8 or 0 or +8, right? Or is it 0 or +8 maybe?
Like the total value of it, or
Yeah. Well, actually, sorry. It would be 0 or 1. Not
yeah,
you,
because
sorry.
if it's -1 to the end, then it diverges, is what we say.
Yeah. Yeah. You
it's-
can't ever. It's like the limit as x goes to infinity of sine of x.
Yeah, because I mean, if we knew if the infinity was even or odd, we could figure out whether it would be a 0 or -1, but we don't know.
Right.
There's no way we can
There's
determine
no
if
way
it's
to
-1
know.
or 0. I guess it could be 1 too.
Yeah. Tuma's in for a.
Had to
in for
help
a
my dad.
treat. Oh, it's all good. It's all good. Do you have any last minute questions about this? Or I think we got it.
Yeah,
Right?
I was gonna ask, in the picture that you drew, the one on the bottom, it's increasing. It's not decreasing.
So the sum is increasing because,
Yeah.
for instance, you would be adding like, I don't know, like this is like 1/8, and then you would be adding 1/64th, and then you're adding I don't know, like 1/256 or something. This is
Oh,
this is
I
like
see.
this is like a running total.
Uh,
You could also think about
also,
yeah.
yeah,
Go on. You're good.
I was gonna say, my other question, well, you're kind of not done, are you?
No, you're good. What's up?
Is when you try to change the Taylor series to like, or the Maclaurin series into the what was it called?
Taylor series into
In that one
into
oh wait, I can pull up the picture.
oh, you're saying like into the series notation
It's
form of
the
it.
sigma, yeah, the
The
sigma,
sigma notation. Yeah, sigma notation.
I noticed that there's not just n, there's also x in there.
Correct. Yes.
So how do you, is that a formula?
So
Because-
yeah. So when you do when you do a Taylor series, right? Whatever. It's like f of x is equal to the summation from n equals 0 to infinity, and then I think it's f prime of is it? I think it's f to the n minus 1 x minus
I think it's just, oh yeah, I know what the formula
over
you're
n
talking about.
factorial.
It's
This is it,
it's
right?
f to the n, yeah, f to the n.
Or f to the
of
n. Sorry.
A,
Yeah.
Yeah.
Oh, is it of a?
I think so.
It is of a. It is of a. Sorry. And then
I
it's
know the
x minus
formula
8.
you're talking
It's
about,
x
yeah.
minus 8 to the n.
Yeah. That's
Yeah.
to go from the Taylor series to the
Well,
sigma notation.
This is a function, and then this is
Yeah.
the sigma notation for the Taylor series.
Oh yeah.
Do you see how this would be like f0 of a, x minus a
Yeah,
to
yeah.
the 0 over 0 factorial, and then it's plus the first derivative at a,
Right, yeah.
x minus a to the first over 1 factorial. Yeah, so this
it's
it's
just
a function of
the
two
series,
things, right? It's
Yeah.
what am I plugging in for x, and then what term am I expanding out to in sigma in terms of n.
And then to go from that to sigma notation, you
Yeah,
just have
going-
to find the pattern. Or
Going
something?
from
I
that
don't
to
know.
that, you have to look for a pattern. Yeah, it's a pattern.
Mm.
But you usually
see.
you'll memorize the ones. It's okay. Like you'll
But-
notice, like, oh, if it's only odd powers, then it's probably, I don't know, sine or something, or cosine. I forget which one it is. And then one of them is only the even powers, and then like the alternating stuff is a -1 to the n, and then a lot of times there's an n factorial on the bottom. So if you start seeing like 6, 120, that type of stuff, that looks like n factorial, or 2n plus 1
All right.
factorial.
But my homework was just so power series. It was just asking if it was converging or diverging. Like that's all it wants me to do.
No, it wants you to figure out what values of x cause it to converge.
Oh, I see.
And what we showed is like that series, because it's looks like a geometric series, that thing only converges if the thing being raised to a power is between -1 and 1.
And we got 8.
And yeah, because our answer was x over 8. So I need this thing to be in between -1 and 1. So x has to be between -8 and 8 in order for that whole thing to be in between -1 and 1.
And then you test the endpoints, but you also
Yeah.
had a negative, so wouldn't it also be -8?
Sure, you could put the and this is what Jeff did bring up. If I plugged in the -8, okay, that would be -8 over 8, which would be -1 to the n. And so that would be -1 to the 0, plus -1 to the 1, plus -1 to the 2, which this ends up looking like 1 minus 1 plus 1 minus 1 plus 1. This still fails convergence because you don't know if you're going to where like you've canceled all the ones or if there's one left over. So it's like either 0 or 1. It depends how far you go. But you have to think in terms of abstract concepts of I go till forever. And I don't know where forever ends. It's kind of like scary, I guess. Start contemplating the function of life.
Oh damn! I put in 8, but I got it wrong. Oh, I have to put it in the sigma notation. And
Yeah,
yeah,
you just have to say comma, like parentheses, -8, comma 8 parentheses.
Oh,
That should do it.
yeah, you're right. Yeah.
Cool.
Okay, thank you.
You're welcome, dude. Yeah, come by. Always bring those questions. I love series. Series are great. And it is a very tough thing. So feel free to
It's
keep
fun,
submitting
yeah.
series questions. They are fun. Yeah, and I'll show you all the other tests you end up using for different situations. The ratio test is like super fun. There's like some cool math.
I've
tricks you
used
do.
all the tests already, but it's just some of them are like kind of difficult. So like I have to keep practicing them.
Yeah. Make some note cards maybe too. You know, if you have like some note card thing based on this, that'll sometimes help you out.
Yeah.
Because I always forget like, you know, what I'm like, wait, does it converge if L is this or if L is this? And like some of them it's I don't know. It's inconclusive if it's inconclusive if L equals 1. I always forget how those ones work. So
Yeah.
okay. Great. Let's go do another question. Cool question. Alright. Choose a winner. Where are you gonna go? Let's go gambling.
Let's go gambling!
You ever seen the Boondocks?
Have you ever seen the Bulldogs?
The Boondocks.
Oh yeah, the Boondock Saints. Tickle my pickle. Wow, one with a 12.4% chance. Should I like even open this question though? I'm like curious. Okay,
I looked at it. I don't think it was that concerning.
Okay.
Well, I
good.
mean, it's statistics, so it's kind of
Yeah, but it's not. It
concerning.
doesn't involve pickles. So okay, we're great.
yeah.
Okay, cool. Statistics. Okay. T-Som is playing a game. She uses a ball, a cup, and a spinner. The random variable x represents the number of spinner lands. The number the spinner lands on when it's spun. The probability distribution is given by the following table. Okay, cool. Oh, so you know this is fun? This is actually directly kind of related to the spinner wheel we just did, you know, for picking this game. Okay, the spinner is spun to obtain a value of X. T-Som then stands X centimeters from the cup and tries to throw the ball into the cup. Oh. Okay. The event S represents the event that T-Som successfully throws the ball into the cup. To model this game, T-Som assumes the probability of... Okay, so I think I get this. Okay. X represents the number the spinner lands on when it's spun. Okay. And so if X equals 80, then they have to stand 80 centimeters away, and then they gotta like do like a beer pong throw for like 80 centimeters. So I'm guessing, yeah, as you get further away, it gets harder. And that does make sense here, right? So the probability of success, given that you landed on whatever this number was, is then going to be K, which is a constant, divided by the number X. And so, yes, as X goes up, you have to stand further away, so the probability of you hitting it is, like, getting worse. Okay, cool. This one, the probability S is in the set of X equals S. Okay, wait. Oh, I see. Should be the same whenever a value of X is obtained for the spinner. Oh, this is cool. So this is saying that the probability of you winning needs to be the same for whatever value of X you get. I think. Okay. And yeah, this is joint probabilities. Okay. Okay, so the probability of S given X equals X, it's like Bayes' law, I think. I think you have to do the probability that X equals X times the probability of scoring given that X equals X. Jeff, yeah? So, for instance, the probability... Yes, okay, good, yeah. So you want the probability that X is equal... So, sorry, that big X is equal to X times the probability of winning. So the probability of winning given that X is equal to X. Okay. The probability of, let's say, for instance, X is equal to A, or X is equal to 20, that would be equal to A, and then times the probability of winning given that X is equal to 20, that's equal to K over 20. Okay. So there you go. So you have so the probability, and then you want that to be the same. Oh, okay. So you want, I see a pattern here, right? So you want AK over 20 to equal the same probability of winning if you rolled a 50, which would be B for rolling the 50, but then K over 50 for hitting it from 50. And then you have CK over 80. And this also needs to equal DK over 100. I think that's correct. And then, okay. But then also the probability of hitting one of those numbers has to always be 1, right? So the probability that X equals like something, that has to equal 1. And that's equal to A plus B plus C plus D, right? Show that C equals 8. Okay. All right. We can do this. This part is pretty easy just to start off, right? Let's do this. Let's do for part A. Okay. So we're just comparing C and B now in this case, right? Doing that, you can see that BK over 50 is equal to CK over 80. So K's cancel. And then I can move the 80 over here, and 80 divided by 50 is 8/5. So then I get 8/5 K, or sorry, 8/5 B is equal to C. Yes. Nice. Okay, cool. Great. Love that. Find the probability distribution of X. Probability distribution of X? Let me think how we do this. Okay. I think I can put everything in terms of B and then put it into this to then solve one at a time for things, right? I think that's how I have to do this. Yeah. Unless someone sees like an easier way to do it. Okay. Because I already have a relationship between B and C. That's great. But then also if I wanted to go between like A and B, that would tell me that A is equal to 2/5 B. And then we need one for D. Then we do these two. We would say that D is equal to 100 over 80, which is 5/4 C. Wait. No. I want no. Sorry, I don't want between D and C. I have C in terms of B. I have A in terms of B. I want D in terms of B. This is what I want. Okay. D is equal to 2B. Okay, very cool. So, A, which is 2/5 B, plus B, plus C, which is 8/5 B, plus D, which is 2B, that all has to equal to 1. Because I need the probability of hitting one of those numbers to be 100%. So that's 10/5. So that's 2, 3, and 5. So 5B equals 1. So B equals 1/5. Okay, cool. All right, now we can start plugging stuff in, right? So if B equals 1/5, then A equals 2 over 25. C is equal to 8 over 25. And then D is equal to 2 over 5. Let's make sure that makes sense. So B and D would get me 3/5. So then I need to know the 2/5. And I will get that from A and C, because 10 over 25 would be 2 over 5. Cool. All right, nice. So we found the distribution. Cool. We did that. That was good. This is a fun little puzzle. Kind of enjoy this one. Nav tries a large number of times to hack the planet. Is that a pager? What's up, Martin? He successfully gets the ball in the cup 30%. State giving a reason why T-Sum's model of this game is not suitable to describe Nav playing the game for all values of X. Wait. Nav tries a large number of times to throw the ball into the cup from a distance of 100 centimeters. He successfully gets the ball in the cup 30% of the time. Oh, I see. I think because, well, this is him only shooting from 100 all the time, right? And so that doesn't take into account the probability of him getting selected to shoot other distances. Oh, it's Martin. You're the racist person? Okay, cool. Good to see you, Martin. I remember you.
Does it rhyme with bigger?
Bigger.
Oh no.
Or Tigger. Oh, we can't say any more Winnie the Pooh jokes, apparently, right? Yeah. I'm curious with this. I see, because we could actually determine. This is actually kind of cool. We could determine what the rate of winning should be. Oh, did we ever find out K though? Oh, we never found out K either, did we? I guess we could find out K though, yeah? Yeah, one sec. We could figure it out. I'm pretty sure we could find it. Yeah, let's do C. I'm pretty sure we could do it. Right? Okay. Because what was that? That was the 100. Okay. Probability is K over X, where K is a constant. Okay. And then from this... Okay. BK over 50. Well, actually, I don't know if that is going to work. Equals CK over 80. Because I have values for B and C. Yeah, but that doesn't help me. That doesn't help me solve for K. Uh-oh. Yeah, actually, I don't know how you solve for K in this case. Oh. Yeah, I'm not totally sure about this last part. I think because TSOM's model doesn't assume you can just always pick. You can solve for K? Oh, you can always pick. Oh, I see. In situation C. Right. Okay, I got you. Yes. Yeah, you could solve for it, right? Right, because we said that P of S given X is equal to 100 is equal to 0.3, and that's equal to K over 100. So yeah, so K equals 30. But you're right. That breaks the formulas here. Because how we have this set up, if K is equal to 30, I don't know if it breaks it. Does it break it, Jeff? I don't know if it breaks it. It breaks when the distance is too small. Oh, okay. Oh, yeah, wait. Exactly. I like that. Yeah. If K is 30 here, then that's 3 over 2. That's 1.5. And then A was equal to this. Is it a 150% chance, though? Oh, no, I see what you're saying. You're saying that if K is equal to 30... Yes, okay. Got you. Okay. Okay, yeah. Then we would say... Then PS when X... I see exactly what you're saying, Jeff. When X equals 20, that would be equal to K over 20, which would be equal to 3/2, which is equal to 150% chance. And that is not possible. Beautiful. Okay, cool. I think we got it. We did. Nice. Great question. I like this one. Pickle. This is a fun one.
Well done! Well done!
Whew, man. Alright. So let's add that question to the form. There we go. There's an answer. Tuma, I should have given you credit, by the way. Sorry. I forgot to do that. Or I guess Maythan is your name now. There we go. Okay, let's go see. Next question. What do we got? All right. Let's go choose a winner.
Let's go gambling!
I like how Ace had the highest chance of getting picked, but still hasn't gotten picked. The shadow ban is real, dude.
Oh no.
Ace, you had the hugest chance of getting picked, I think, right? But consistently has not gotten picked. Maybe breasticles, I should do that, right? I should put like a sneaky shadow ban on things where if you do submit like too far before, you instantly get your chances hampered by like a factor of 10 or something. But it doesn't show it. That would be kind of fun. Yeah. Ooh, I like that idea. Let me put that down. All right. Determine all critical numbers. Determine the max or min by using a chart. Make sure to state whether it's a max or min. List all answers as a point. Oh, cool. Or they at least gave us the function. They gave us all the derivatives. What's up, Justin? Good evening to you as well. We're doing some, looks like this is a calculus question. Okay. Critical numbers is when f prime of x is equal to 0. What's up, Ace? So let's set this equal to 0. 0 is equal to 2x times x plus 5 over 2x plus 5 squared. Ooh, okay, I like that too, Bresco. That's a fun one. Yes. Also, a critical point is when the denominator is equal to 0. Yeah. And I guess that could be a max, right? Because if it's not a local max, though, right? Yeah, because if you're dividing by 0, you're either going to negative infinity or positive infinity. All right, well let's figure out when f prime is equal to 0, because those are like the simple critical numbers I like. So that only happens when the numerator is equal to 0. So either x equals 0 or x equals negative 5 for the numerator to be equal to 0. And then yes, technically, or x is equal to negative 5 halves means the denominator is equal to 0. And then this is like, divide by 0 is like bad. It's either like plus or minus infinity. Do y'all consider the endpoints to be critical numbers? No. I think there are things you need to check for sure. They didn't say that if we have any endpoints on here, I guess, right? Okay. And then they say use a chart. Okay. I think usually the chart is this. It's usually, we're going to say like x, and then we can say like f of x, and then f prime of x. And then you can also do f double prime of x. And then let's put some numbers in. What's up, Bella? What's up, Pineapple? Oh, all good. You were studying for English test? You also have and you also have a test on this in math. Okay, cool. So yeah, let's put in our critical points. So 0 is definitely 1. Negative 5 is also 1. And then I guess we will also put in the negative 5 halves. Just for fun. Okay. Because the derivative here is going to be 0. So that tells me the function is like flat. Which is fun. I'll put like an arrow. I know the function's flat here. And then here, at negative 5 halves, the denominator is 0. Let's see. Well, let's see. This would end up being positive, right? We could actually do a limit here. We can say like the limit as x approaches negative 5 halves of 2x x plus 5 over 2x plus 5 squared. So the nice thing is I don't think we have to do from the left and from the right, because this squaring will always enforce this to be positive. If there wasn't a square here, you would technically have to do from the left and from the right, because this is either like a really small negative number, like I say like 0 minus, or it's a very small positive number, which would be like 0 positive. but because you're
2 a.m.
squaring,
here.
is it 2 a.m. over there? What time is it over here? It's like 6:20, I think, over here. Yeah. 3 a.m. in Denmark. Wow. Ooh, and another Netherlands person. Love all the international. Okay, but if you were to plug this into the top, right? So this will always be, I'm going to call this like 0 plus. This will be a positive 0. This is going to end up being -5 times a positive number. So that's going to be negative. Because -5 + 5 is still positive. So this is going to be equal to positive infinity. For sure. Okay. Okay. So I think I can just say this is infinity. Which means it's going to be asymptotically.
I think it should be negative infinity.
Negative infinity, sorry. You're right. Dumb. Negative over a positive number is negative. Thank you. Thank you.
I actually only got it because I was curious and just pulled it up on Desmos.
Yeah. No, you're right. Okay, there you go. That way. Yeah. My brain. I'm still recovering. Okay, so then you can plug values in to see what the function would be. So at -5, so that's plugging into here, we would get -5 squared would be 25, and then 25 over -10 plus 5 is -5. So 25 over -5 is -5. Yeah, great. Love that. If it's 0, this is just 0. Okay. And then at -5/2, okay. This is where things will change, actually. Because this is 2x plus 5. So we actually, we have to look at the function this way. So limit as x approaches -5/2 from the right.
Also, shouldn't the negative infinity be the f of x value?
That's the f prime value I did. That was me plugging into f prime of x.
Oh, they give you f prime of x. I thought that was.
Yeah, no.
X.
This is f of x. This is f prime of x, and then they give us f double prime of x.
I see.
Yeah.
I see.
I'm just putting in all the values. But here, because this is not squared, my concentration is whack. Good night. Good luck. Oh. Okay. If it's approaching from the left, then this will be negative on the bottom. This will be like 0 minus. So this will be 0 plus if it's approaching from the right. And then this will be, whatever, a positive number. So this would equal to positive infinity. And as x approaches from the left, this would be a positive number over a -0, or like a really small number. So that'd be negative infinity. Oh, okay, cool. So I think it looks like this. Right, it's either like positive infinity to the right of it, or it's negative infinity to the left. Okay. So, and then I don't really know if we need to do the second derivative. I guess we could. If you plug this in, this is negative, which means it's concave down. You plug in -5/2, you get infinity again. You get plus or minus infinity. And if you plug in 0, you get a positive number, so it's concave up. Oh, sorry. Yeah, sorry. From the sorry. Yeah. It's coming down from positive infinity. Sorry. Yeah, let me draw that correctly. Sorry. Here it's going down to negative infinity. And then here it's coming down, and then this is like the border. Okay. And then that's flat and it's concave up. And then we could also see the limit as x approaches infinity. Well, x squared over 2x plus 5, that's just going to be positive infinity. And then for negative infinity, it would be negative infinity. Okay. So do they want us to graph it? I mean, I think the max is equal to positive infinity. Min is equal to negative infinity. Yeah. If you wanted to know like what this is technically a local max, and then this is technically a local min, I think. So, in my estimation of what this would look like, and then we'll check with Desmos. If I were to graph this, I know at -5 there's an asymptote. So this is at -5, and I know it must like come down from infinity, and then at so 0, 0 is a point. Great. Also -5, -5 is a point. So I don't know, just doing stuff. And I know it has to kind of do this, I think. And then it's going to do this. And then for this... yeah. I want to say the function does this. Does that look about right? What it should be? Oh, okay, cool. Yeah. Basically. I mean... My curvature doesn't look as nice, but it is kind of the same thing. Cool. Yeah. So the max is at positive infinity, min's at negative infinity, and then yeah, you have this slant asymptote that's happening. I guess I really should have drawn something like that. Yeah, and actually we could have seen this from here, right? If I wanted to do the equation for like a slant asymptote, I think if you do polynomial long division, you would see that that's equal to like y equals 1/2 x or something. 2/5 or something. Dr. Gold, the x equals 0 part is... The x equals 0 part, it's 0 from 2x. Yes, from this part. Yeah. So the range of the function... Do I need the range? I think they just wanted the max or the min. But yeah, this pineapple, this is what causes the numerator to be equal to 0. And causes there to be a critical point because then f prime of x equal to 0. But okay, yeah, if you wanted to write out what the points are, like -5, -5 is a local max. 0, 0 is a local min. And then the absolute max and min, I mean, infinity, infinity, do they count that? Or do we say there is no global max? Then I don't know, really. Is global min. We also didn't like define where it was. Range would be -5 to 0. Well, I think it doesn't. It's everything except for -5 to 0, right? Is that what you put the negative in front of? Okay, cool.
Yeah, that's saying the set R minus the set 5 to 0.
Right, I get it. It's all real numbers. Yeah. Y can take all real numbers except for -5 to 0. Correct. Okay, cool. Thank you, Boobicles. All right, cool question, Lucky Cat.
Well done.
Does that make sense, Pineapple, how we did that? Yeah, for sure. Yeah. What's up, Sensation?
And then you probably never seen that movie. Dude, Where's My Car is one of those movies.
Yeah, it's like Pineapple Express.
It was good at the time, but it's just so bad
absolute
now.
shite now, dude.
Huh?
No. Dude, I had that realization with like Lord of War. It used to be like my favorite film ever. And then I like got older and started analyzing Nick Cage's acting, and I was like, oh no.
Surprise, motherfucker.
I've been lied to this whole time.
As long as you understand that the story's real.
The story is real though, yeah. And we actually recently traded Orlov for Brittany Griner, right? That's a real thing.
Why?
Don't
There's a
ask
lot.
me.
Yeah, don't ask about that. Yeah, that's like,
If you ask me though,
why?
this movie will always be Inglourious Bastards. Always on top.
Inglourious Bastards is great. Yes, I will agree.
That
That's a great movie.
is awesome.
That movie is phenomenal. It's a great film.
I'm sorry. That actually happened. The US traded a
Yeah.
well-known
Brittany
arms
Griner.
dealer for
Yes,
an
for
NBA
Brittany
player.
Griner. Yes, correct. Yes,
Not
And-
just an NBA player, a WNBA player.
WNBA player.
Somebody-
Sorry. Yeah.
Somebody needs to be hanged for that.
Oh
The problem is like it was too much of a PR thing, man, dude. Also, Russia was playing dirty because they busted her for like some like dump. It was like a weed pen or something, and they're just like, yeah, you're here forever now. And at that point, I think U.S. citizens started getting wise to be maybe we shouldn't go visit Russia because they're gonna start targeting citizens as hostages. So I think she was over there because the WNBA doesn't pay very much in the US, and so how they make money is they go to other countries to play during the off season. So there was that microcosm happening as well, which is like, well, we don't pay WNBA players enough, so that's why they had to go to Russia. But then you can be like, well, because people don't want to watch the WNBA. But now they do.
Yeah, I was
With-
gonna say.
It's switched. It's switched now because of what's her name, Caitlin Clark, because she's actually like a pretty cool person to watch play, and like the game's interesting again. I don't know. I don't go to basketball games. I think basketball in general is just really fucking boring. So I wouldn't watch it if it was men's or women's.
I'm not a fan
You
of
still
sports because
only
nobody
watch-
dies. So.
Nobody dies.
Let's go gambling!
That's the point. If it's gladiatorial combat by any other name,
You want the
somebody has to die,
gladiators?
or else it doesn't mean anything.
Breasticles!
Go.
Wow, the shadow band of Ace is real, dude. Maybe I don't even have to do
It is.
anything. It's just happening.
I guess not.
Okay, cool.
I was looking for a PDE problem, but I didn't have time.
It's
In order
okay.
to make a absolute monster with Kirchhoff problem.
Ace says, "I don't know." We don't know Ace, honestly. So Ace, we were gonna say that like technically you should only submit your question like maximum like 30 minutes before the stream starts, because if you submit it hours beforehand, then it racks up like a ton of votes, which isn't necessarily fair. But then what is funny about this is that even though you have all these votes, you somehow haven't gotten picked. So the picker wheel does have like a bit of justice in it, which is funny. Yeah. Anyways. Yeah. Okay, let's try to do this one. The wheel of justice. Yeah. All right. I'm thinking we want to do a Feynman trick, right?
Yes, we do.
Let me think if I can like determine what the Feynman trick would be. I want to say I want to take the derivative of ln of something like dd. Am I going to do DDA, right? That's what I'm going to say?
Yeah,
Okay.
they already. A's
Okay.
already there for you.
Got you. Oh, okay. So I'm going to say dIDA is equal to the integral from 0 to pi dDA of ln of 1 plus a cosine of x. I might be getting better at this eventually. This would be really cool. Okay. And then I know what the derivative of ln of something is. This is where you have to remember kind of intro calculus, right? ddx of ln of x is equal to 1 over x dx. May the Schwartz be with you. That's another good one. They're remaking Spaceballs, aren't they? Anyone know what Spaceballs is? Am I too old?
Yeah, I remember it, but I don't know if they're remaking it.
I think they are remaking it, dude. I think there's a new Spaceballs coming out. Spaceballs 2. Beautiful. Is he still alive? What was his name? Mel Brooks?
Is Mel Brooks?
I think so.
Is he? Is he still
Barely.
alive? He's the one that created it, right? Isn't that's his thing? Mel Brooks?
I think Mel Brooks is 99.
Wow.
Oh, yeah!
That's pretty cool. All right, so it's 1 over that, but then the times the derivative of this with respect to a. Oh, that's going to be cosine of x.
Yep.
And then dx. And this is equals to di over dIDA. Okay. Well, it didn't get rid of the a, but I don't know. What is this? Like integration by parts now?
This would be a Weierstrass substitution.
Oh, okay. So I have no clue what a Weierstrass substitution is.
It's a happening. substitution, or a tangent half angle substitution.
Weierstrass. I'm gonna do the. I think it's like that, right? Don't they do the weird B or something? Beta.
I don't know. I just wrote it with the.
So
SS, where I
JH
just wrote tangent half angle substitution.
So JHNat, the derivative would kill off the integral if this was ddx. The key thing here is this is dda. So the integral is in terms of dx. So it actually just hits this. It doesn't undo the integral yet. Oh wow, Rick Moranis is finally coming back to like a he gave up film. Like he made a bunch of money and then he was like, I'm out, peace. Probably one of the smarter ideas in Hollywood. But wow, he's coming back. That's so cool. Yes, it's primarily a parody. I wonder how they're gonna. There's so much to make fun of Star Wars these days. Oh, you don't have a full screen? Okay, I'll get it, Jason. Okay. The Weierstrass substitution transforms the integral of the form f of cosine theta and sine theta equal to a function of 1 minus t squared over 1 plus t squared, comma, 2 over t, 1 plus t squared, 2 dt, 1 plus... Okay. So, do I just replace cosine of theta with this? And then I have to slap this on the end?
Yeah, so every cosine term would become, that 1 minus t squared.
Oh, okay.
1 over 1 plus t squared. If we had a sine term, it would become the
2t over 1 plus t
2t
squared.
over 1 plus t squared.
That's
and then
cool.
your dt becomes that.
And so this is just like a well-known
2
trick.
over 1 plus t
I'm sure we could rederive it. I don't really want to.
Yeah.
But yeah, okay. All right, so dA is equal to... Am I going to have to redefine my bounds now? Probably, yeah.
Yeah, you could, or you could just substitute back in.
All right, we'll substitute at the end, I guess.
Later.
Well,
Actually,
that's assuming I get this
slightly
shit back.
different.
Yeah. I probably won't.
Yeah.
Okay, so dx is now equal to 2 dt over 1 plus t squared.
Mm-hmm.
So, converting the bounds is very excited for space walls too. Nice. Okay. So, let me think. So x goes from 0 to pi, or I guess dx goes from 0 to pi. So then I have to figure out like what I guess dt goes from. Is that how this works? Or
you could just plug in your 0 and
we can do this. Or no,
x, plug in 0.
Can we do this? Where t is equal to tangent of theta over 2?
Oh yeah, you could do that too.
Let's just do that.
Yeah, actually, that's
right.
easy.
Yeah, let's make that much easier. All right, so t is equal to tangent of theta over 2. So if theta went from 0 to pi, then t goes from tangent of 0 to tangent of pi over 2, which, yes, tangent of 0 is 0. Great, Justin. And tangent of pi over 2, that's where you're up here. Your opposite is 1. Your adjacent is 0. That's positive infinity. Okay, cool. So now we're going from 0 to infinity. And then this is going to be 1 over 1 plus a 1 minus t squared over 1 plus t squared times 1 minus t squared 1 plus t squared. And then this is also times 2 dt over 1 plus t squared. Okay. This is kind of a mess, though, dog. What? Do I want to like start multiplying things in? Maybe.
Yeah. I'd just that's probably what I would do.
Probably what we do. Yeah. All right, let's do it. All right. So 0 to infinity. I am gonna have a 1 minus t squared on the top, and I'm also gonna have a 2.
The squared should be on just the t, not the whole 1 minus t. You wrote the 1 minus t.
No, I fucked up.
Not that guy, motherfucker. Trust me.
Yeah,
You're not that guy.
I fucked up. Dude. Okay, that's what it is. Yeah. Okay, and then this is going to kill this off and put 1 on top, and then this is going to have 2 of them. So we're going to have 1 plus t squared squared plus a 1 minus t squared 1 plus t squared. And then this is still dt. Okay. Still not a very nice integral. Am I going to say u equals 1 plus t squared? We're doing another u sub or something. It's kind of like my next option here.
I'm thinking I haven't fully solved this one yet. I threw it into ChatGPT to make sure it had a clean solution, and then
okay, let's just say let u equals 1 plus t squared.
Yeah.
Right. So then du is equal to 2t dt. Okay. Because then I'll get u squared plus 1 minus t squared u. No. Issues. I gotta get rid of the one.
I see what chat did. That actually saves the algebra a lot. They don't
What did they do?
steps of it, sort of. Whenever you have the cosine of x over 1 plus a cosine of x, they call it, now use the algebra trick is what they say, but you could say 1 over a multiplied by 1 minus 1 over 1 plus cosine of x, a cosine of x.
Okay. So sorry, when we're here, they
Yeah,
don't do a Weierstrass substitution.
No, they do a Weierstrass substitution. They just they do a simplification of the integral using.
Okay.
I don't know what algebra trick they're talking about.
All right, let's see what this
Off the
is.
top of my head, I'm sure I can figure it out. But
I'm okayato. This is I think this is partial differential equations, maybe, or no, or this is just like really
this
tricky
is
integrals.
this is just calculus. They never really teach Weierstrass substitutions for some reason, but it's
Is this like, are we doing like partial fractions? How does this turn into this?
I was wondering that myself. I don't know exactly what. Let me actually ask chat what they do because they don't explain it.
Maybe they multiply by the conjugate. If you multiply by 1 minus cosine x, 1 minus a cosine x. Just curious if that works.
Oh, actually, yeah, I think that is what they do.
You just multiply this
by
on the
1
top.
minus a cosine of x. You get on the bottom. You would have your 1, and then your a squared cosine squared of x, and then
so that's cosine of x minus a cosine squared of x over 1 minus a squared cosine squared of x. I don't know. Then I'm gonna get like a sine squared in there. I don't know if I want that.
Oh, that's not what they do. They
No.
they
Justin's
say
right that like
start-
if we made common denominators, we probably could get it. I just want to know how they get from here to here. I know you can go backwards, or I guess you could just do the reverse operation. I was hoping that maybe that would like do it. Okie dokes. Let's see. We're getting sentenced to algebra hell. Okay. Start with that. Subtract 1. Okay, cool. Now divide by a. Okay. So cosine of x is equal to that. Now divide both sides by 1 plus... Oh, so you're just like rebuilding it.
Yeah, pretty much.
Oh, that's cute. I don't know. This feels to me like if I know what the final answer is supposed to be, then yes, I could like come up with a way to do it.
Yeah, that's my issue with chat sometimes. They're just like, use the algebra trick. And
who
I'm
in their
supposed
mind
to
would
just
come up
know
with this?
algebra trick off the rip.
Yeah, I would know this off the rip.
That
Okay.
makes sense.
All right, so we should get rid of this then. No. Because this is like too hard.
Yeah, get rid of
Just
that.
get rid of that. I mean, we can still keep our bounds. Still keep our bounds.
I'm sure it would work out relatively easy, but
That's the main way for evaluating integrals. Yeah, just know what the answer is supposed to be.
My man.
Yeah. Yeah. Brasticles does this thing where they'll just type in random crazy hard shit to solve, and as long as there is an answer, they'll try to reverse engineer it to see what they could get. It's kind of cool. You definitely learn by reverse engineering things. That's how, I guess, the Chinese copy all of our military stuff. Okay. So let me do the substitution first. Okay, so I'm gonna say that so we're gonna use this algebra trick, this cute little algebra trick that our AI overlords have come up with. 0 to infinity, and then wait a minute. Okay, yeah, is 1 over a. 1 minus 1 over 1 plus a cosine of x. Yeah?
Yeah. Our bounds
wait, sorry.
be the original bounds, though.
That would yes, right. So those would still be the original bounds. And then, well, I probably want to separate this. This is like an easy integral to do, right?
Yeah, and you can pull the 1 over a out of the integral because that's a constant with respect to x.
Okay. So I'm going to say integral from 0 to pi of just dx, right? That's easy.
Mm-hmm.
And then this is the one I'm going to do the wire stress on.
Yeah, and that one with the wire stress is pretty easy.
So that's going to be from 0 to infinity. And then that's going to be 1 over 1 plus a, and then that's 1 minus t squared over 1 plus t squared times 2 dt over 1 plus t squared. Okay. Yeah, sure. So this is just pi over a. Or this is also 1 over a, sorry. So this equals pi over a. And this is minus. Okay, yeah, minus 1 over a. Is this easy? I guess this will cancel out this one, right?
You gotta just simplify your denominators here.
All right, let's just do it. Okay, so from 0 to infinity, and then that's going to be 1 over 1 plus t squared plus a 1 minus t squared. And then there's technically a 2. Let's pull the 2 out. Pull the 2 out here. And then this is dt, yeah?
Mm-hmm.
Okay. Pi over a minus 2 over a. 0 to this. And then that's 1 over... Interesting. Okay. I don't know. That's 1 plus a plus t squared minus at squared. BT?
Yeah, that seems correct.
Can this be made easier? I don't know what to do with... Maybe I should group it by t squared?
Yeah, it should be able to factor to 1 plus a and 1 minus a times t squared.
Okay. Okay. So I have 1 plus a, and then plus 1 minus a t squared.
Yes. Over dt. Yeah.
Good. Okay. Do I need a is this partial fractions now? Because this is a quadratic and... Oh, it's not even a quadratic, sorry.
Because it should work out in some way to an arctangent.
Arctan? Hmm.
Yeah, because see how if you say, right, 1 plus a as value, 1 plus a is a constant plus t squared times a constant,
Mm-hmm.
which is kind of a general arctangent formula.
What?
Look up the exact.
You want me to call this like, I
rectangle.
don't know, like W? Call this like Z?
Yeah, you would have like
I think I see. I think I see what you're saying. You're saying
1 over W squared plus.
Yeah. I'm gonna pull out the
U
1 minus
squared.
A. I'm gonna pull the one minus A out. I think that's what I'm gonna do. I think I say 1 over 1 minus A. Okay, so then I can get rid of this. And then this would be 1 minus A times 1 plus A. So this would be 1 minus A squared. I think. Yeah. Like that. And then this
Yeah,
kind
that's
then
correct.
this looks like arctangent. But with this being something.
Well, that's a constant. So we can just say the square root of 1 minus A squared as your constant there.
Okay. Oh, I think I see what you're saying. One second, let me pull it up. I forgot what the arctangent integral is.
Yeah, it's A squared plus U squared is 1 over
This
A.
is it. This is it.
arctan
This is it. Yep.
B over
Yep.
A plus U.
Got it. Oh wow. What fun. I see. So this is now my like de facto A. Okay. So I have pi over A minus 2 over A, 1 over 1 minus A. And then we still got the integral. So this is going to be 1 over 1 minus A squared. Arctangent of T over 1 minus A.
Those should both be square rooted.
Correct.
Because 1 minus A
Correct,
squared is
correct,
a
correct,
different
correct,
perfect
correct.
square, so you gotta,
Correct.
you gotta take the root of them.
Square root. And then this is evaluated from 0 to infinity. So as long as A doesn't equal 1, we're okay. Right?
Mhm.
But yeah, so arctangent of 0 is just 0. And then arctangent of infinity is pi over 2. Right?
Yes, I believe
Okay.
so.
So we have pi over A minus 2 over A, 1 minus A. And then this is going to be 1 over the square root of 1 minus A squared. And then this, again, I don't care about the 1 minus A on the bottom, because infinity and 0 are just extreme things. So this is just going to be pi over 2. And then this is all equal to di dA. Does that look about right? But then I got to go integrate all these with respect to A again, dude. Like, what?
Disqualified.
I guess this isn't bad.
This
is
the
a
one.
secant.
The 1 minus A, I don't believe is there. It should work out to pi over square root of 1 minus A for that right term.
This should all just work into what? Sorry.
Pi over square root of 1 minus A squared.
Okay, so you didn't like these things?
Yeah, the 2 is fine for something about the
Something about the over A 1 minus A thing?
A, but let me see what the. Well, eventually the whole I prime of A should turn into a pi over A times 1 minus 1 over 1 minus A squared. ChatGPT did it a bit differently. They solved that for K of A. So they said pi over A minus 1 over A K of A, where K was that integral, and then they solved for K of A. So there should be the 1 over A, it's just that 1 minus A on the bottom that's problematic.
Yeah. You're saying this one right here is problematic.
Yeah, just that one.
Were we okay up to here?
I believe so. They also did that step a bit differently. They didn't.
So I wrote this as
include the,
1 minus
DT.
1. I wrote this as 1 plus a times t squared 1 minus a. And then I pulled that 1 minus a out of the whole denominator. So that's what left this as a t squared. But then this is 1 plus a. So if I pull a 1 minus a out, oh, I see. One sec. I see where this is wrong. I think this is 1 plus a over 1 minus a.
Yes. Yeah, that seems correct.
Got it.
Yeah. Okay. Yeah. That's what that's. What
Okay. And then, okay. So, but then this is the square root of all of that, I guess, right?
Yeah.
Uh-huh. Okay, 1 minus a, and then this is the square root of 1 plus a, 1 minus a. So then, yes, when this comes in,
okay,
this comes inside as a 1 minus a squared.
1 minus a cancels.
Cancels out one of them. So then you get, cool, yeah, whatever, that goes away, great. And then the 2 cancels with this, I guess. So then I get, very cool. Okay, so this is pi over a, and then that's 1, because this is another pi over a. 1 minus pi over the square root of, no, sorry, 1 over square root of 1 minus a squared, I think.
Yep.
Nice. Oh, man. Okay. So then I just move this over. Shameless plug. Yeah, cool. Yeah, Justin, we always raid you after this stream. You're our Monday night math guy, Justin. Just be a Calc 2 review. We'll be doing intro to Fourier series. Nice. Beautiful. Yeah, we have other people here who are asking about series. So, yeah, we are 100% going to raid you, Justin, after this anyways. You're my Monday night math guy. No one else streams really this late on Monday. Yeah, anyone that's watching as well, if you ever want like a calendar for when we do stuff, some of the other streamers that do math and science are on here. But yeah, we're the only people really on Monday. But we have a lot of other cool streams coming up. MathPon's going to be back doing streams on Tuesday with Complex Power Series. Zach's going to be doing some math tasks. Penn Center is going to do Let's Destroy AI Shooty Shooty. I have no clue what Let's Destroy AI Shooty Shooty is, but that Penn also has some math stuff as well. And then yeah, I'll see if we can do a Gilded Method stream. That'd be fun. Anyways, there's a lot of stuff going on. But yeah, we'll check out Justin's stream after this. Okay. Okay. Seems like a fun stream, right? Yeah. Okay, so then the last step is integrate, right?
Mm-hmm.
Okay. So this is going to get me I is equal to the integral of pi over a dA. So that's pi ln of a. Minus... Well, this integral's not so nice. Pi over a square root of 1 minus a squared dA. I almost want to say u sub, but no, right?
Oh, well, I believe it's either a
this is arc
secant
secant.
Hyperbolic.
Yeah, it's this one maybe. Is it hyperbolic?
I think it's hyperbolic because I believe the hyperbolic is a constant minus the u rather than the u minus constant.
This is it. Yeah, it's this one. It's hyperbolic secant, I think. See you, dude. We'll see you, Justin. No, this is Patrick. Who's Patrick? Okay, cool. Yes, it is. Well, fuck. Actually, wait, what?
Really wish I could do that voice.
No, this is Patrick.
Is mayonnaise a vegetable?
Mayonnaise.
Or something else? Is mayonnaise an instrument now?
Is it Kosiksh? Is it Kosiksh? Arc? Sorry, is it Arc Kosiksh? Gladiator's procrastinating. Don't do it. Gotta do your work. See, the issue is here that, like... I think it's just secant. Yeah, I don't think these work. One
Yeah,
sec.
yeah.
I'm getting
I think
confused
I
with all
just
the A's.
was misremembering.
Yeah, I think it's inverse trig integral. Yes, I think it's this one, arcsecant. There we go. Well, wait, I need 1 minus
No,
a
I think it's-
squared.
It's arc hyperbolic secant.
Arc hyperbolic
There's a negative
secant?
difference. Yeah.
Stop. Get out, dude.
Yeah, here we go. That was what I was thinking.
Thank you. Okay.
I can never find the.
Okay,
Yes, I
there we
used
go.
to have like from Calc 2 just a list of all of them, and I lost it.
Got it. Okay. Good, because the derivative of u, in this case, derivative of a is just 1. If it wasn't, we'd be in a lot of trouble here. Okay. So, okay. Pi ln of a. And I'm going to put another... I'm going to say plus pi arc arc hyperbolic secant of a. And then we're done.
Mhm.
Yeah? This is I of a.
Yeah, and then that's I have it.
Look at this massive journey we took along that end. We did it. We did it. Very cool. I like how we found our error there too. That was cool. Along the way.
Yeah, that's what's nice about chat. Is it,
Yeah.
you can be like, wait,
This is why AI
it's
is
not
useful.
correct. Am I correct? Or is it?
Because you can just go back to the steps and be like, okay, wait, where do we agree up to? And then like, where do we disagree? And then I see that, oh yeah, maybe I shouldn't have done that. I would say I amount that question similar to going to the gym. I feel like I'm getting better at math just by doing tough math for the sake of doing tough math. It's like lifting heavy things just for the sake of lifting heavy things.
I agree. It's very helpful.
This was cool. I'm getting more and more comfortable with the Feynman trick too. And then that
Yeah, it's a
Weierstrass
really
substitution
like
is cool.
neat technique. It's one of the first ones I go to whenever I see a definite integral. I'm like, wow, I can't really solve that easy because it lets you turn a really shitty integral into something that you can
into something that
work with.
it's almost kind of like reverse chain ruling kind of. I'm trying to think about it.
Kind of. I think of it like a in a way almost like an integral transform.
Integral
right?
transform,
because like in a Fourier transform, you're like, okay, well, this really sucks to solve in
this space. Let me put it in another space.
But let me put it in a frequency domain, and it works really easily. But here it's like, wow, this integral is really shitty to solve.
Yeah.
As an integral, but what if we had a way to convert it into a PDE that
I see.
Is
and
pretty easy to solve.
The reason why it's a PDE is that you're taking the derivative with respect to a different variable. This is technically a partial, I guess.
Yeah, and then once you get into the A, it's
into the A domain, and then we go back.
A function of X as well.
Cool. I learned so many things today. All right, nice. Great question. Let's go see who's next on the list. Op amps. Don't need to know that. Okay, cool. Cool way of thinking about it. Yeah, it is really cool. All right, let's spin the wheel and let's choose a winner.
Let's go gambling!
Also, I guess another reason why it's a PDE is technically you can do this for an indefinite integral, but you never see it happen because once you integrate, since you took a partial derivative, you don't get a constant c. You get a constant function in terms of alpha or whatever the parameter is. Yeah. That then gets kind of difficult to solve.
Yeah, because then you have to know how like alpha moves. Yeah.
Yeah.
Okay, Ace escaped the shadow ban. Congrats, Ace. Okay. New anti-frost solution. While the primary effect is okay, the mixture in the water will also release heat. Okay, cool. That's fun. The water releases heat as it freezes. Oh, I guess it does, right? In order for something to freeze, you have to lose heat. So the heat then what melts the ice? Is that kind of that works for antifreeze? It's kind of crazy. Okay. All right. If 100 kilograms of the water content in the spray solution were to freeze during a cold snap to protect the plants, use enthalpy calculations to help explain why this practice would prevent the plants from freezing. Hint: delta H freezing is -6.03 kilojoules per mole for water, which is the energy released by liquid water to freeze. Okay. 100 kilograms. Okay. So, delta H for the spray. Or I guess we should say Q. Sorry, not delta H. This is the heat released from the water as it freezes. That's going to equal N delta H freezing. You're right, JHNet. Yeah, AI does like it messes up on like how many R's are in strawberry too. I think it messes up on that one as well. There's a bunch of like funny ones it works on. Okay. And this needs to be a number of moles. So I have to know how many moles is equal to 100 kilograms of H2O. And what I know is for 18 grams, so for, okay. 1 kilogram is 1,000 grams. And then 18 grams is 1 mole of H2O. I think so. Right. H2, oxygen 16. Why do they say for the liquid water to freeze? Water is liquid, otherwise it's ice or steam. Well, no, technically H2O is water. And then, depending on what phase it's in, right? So H2 as a gas, water as a gas is steam, you're right. Water as a liquid is liquid. Water as a solid is conventionally ice. Yeah, exactly. Okay. I see. So in order for the water to freeze, you need to release this amount of heat to... Okay, and let's see how much heat that is. Calculator. Okay. So we're going to do 100 times 1,000 divided by 18. What's up, Dylan? Okay. So that's a bunch of 5s. So I'm going to say 5.5 repeating kilojoules of heat. Great. So then why would this prevent the plants from freezing? Like, cool. I found out the amount of energy. 100 kilograms. Yeah, I'm just confused. Like, what do they want? I'm like, cool, yeah, I calculated this number, but like, wait, what do you want with it? Maybe I need to know the enthalpy of what's the specific heat of methanol, maybe? Yeah. Here, we can also just throw this in the chat to see what it says. It could be just a badly written question. Or here, let's use Claude. Claude's pretty cool. How can you help me? Try to solve this. Yeah, I use all of them. At the phase transition temperature, the heat capacity, don't hit your token limit. Yeah, they are bad about tokens on Claude. Okay, at the phase transition temperature, the heat capacity takes a step down, so to speak. If you plot enthalpy on a phase diagram, the phase transition is large. You need to calculate the change in the melting point. Interesting. Oh, okay. Am I going to do that for methanol? Or am I going to do this for like is equal to MC delta T for water? I think maybe this is what we're going to do. So 5.5 times 10 to the 3 joules is equal to 100 kilograms of water times 4.186. Oh, so I should do 100 times 10 to the 3. And then I guess this is delta T, right? And that's the change from 0. Because this is the amount of heat. This is the change in the temperature of the water, right? The water's going to heat up, I guess. So this goes away, this goes away. So I get 5.5 is equal to 100 times 4.186. Delta T. It's not going to be very much. I don't like that. Let's see. Let's see if... Okay. Oh, interesting. Did I not get the right answer? Oh, yeah, duh. Wait, what? This is just the number of moles. Oopsies.
Oh no.
Oh man, dude. Sorry. I didn't even calculate the. Sorry, that was yeah. Okay, 5.5 repeating times 10 to the 3 moles. There we go. Yeah. Nope. Okay, so 5.5. This is where AI is useful because it shows me that like wow, I made a really dumb mistake at the beginning. Okay, and then delta H is negative 6.03 times 10 to the 3 joules per mole, right? So now if we multiply that together, yeah, you would get this negative 33,000. So that's a lot of energy. We can do that. 1 second. Yeah, so you get 33, you get a lot of zeros, so let's divide that by 1,000 again. So I get 33,000 kilojoules, 33.5, okay. So negative 33.5 thousand kilojoules. So I guess 33.5 megajoules then, right? Is what I would say. I think megajoules, yeah? Okay. So then when you got that, this is a massive amount of thermal energy transferred in the environment at the surface of crops. As the water in the sprays in this freezes during the cold snap, this exothermic phase change releases heat directly onto the plants. That released energy raises the local temperature of the plants just enough to keep the plant tissues from freezing and ice crystal damage. Essentially, the water sacrifices itself by freezing so the plants don't have to. Yeah, it is a weirdly phrased question. I think they just wanted you to come up with the number. And then you're just supposed to say, like, yo, that's a lot of heat. I started scrolling on YouTube and came across you, so I stopped doing scrolling. Great. I'm glad. That's the best way to learn. Doom scrolling turning into productive things. Yeah. So I think... yeah, Ace, this is a weird question. I think you're just supposed to calculate this and then recognize that like a megajoule is like, it's a lot of energy. And that would raise the temperature of the surroundings. Yeah, so maybe, yeah, I feel like this looks cool. I think you're just supposed to say it's a lot of heat. I don't know specifically. It depends on the mass of the plants, you know. That's Gemini. Okay, cool. All right. Yeah, cool. All right, cool question. I didn't know about that, about antifreeze. Now I learned. What class is this for? Is this for AP Chem? All right. Let's go choose another winner. Who do we got?
Let's go gambling!
Regular Chem. Eagles! Eagles. From Denmark. Oh, wow. What language is this in? Hurry, Danish. Hvor elke vada van K met K. Okay, I need to go translate this. You don't need thinking. Give me some translation. Okay, FK is a catenary. On the points. Okay. Let me get the English for this. Catenaries. Doesn't this become like arctangent or something?
That becomes a Koch curve.
Koch? Yeah, is it Koch?
Well, the K is different, but the E to the KZ to the, or E to the KX plus E to the minus KX is 2 Koch of KX.
Oh, this is Koch. Yeah. Tegan says, I'm doing this right now. The algorithm knows, dude. Algorithm just heard me say catenary, and it's like, yo, go find people doing this. Okay. On the graph, f of k, 2 points P and Q are defined, okay, with the same y coordinate, sure. Okay. The length of the part of the catenary between P and Q is denoted by L. So this whole thing is L. The lowest point T lies on the y-axis. The distance from T to the horizontal line PQ is denoted by D. It holds that K is related to the distance that it droops. Okay. In the figure, they did K equals 0.7. XP was equal to 3. XQ is equal to positive 3. Negative 3. Okay. Calculate for in the situation in figure 1, the length of the catenary between P and Q. Oh, so this is just an integral, no? I think this is like an arc length type thing.
Yeah, it should just be the arc length of the curve.
Yeah. Okay, so arc length, which may end up being a nasty integral. Arc length. I see, because K. Well, they told me what K is actually. Oh, I'm already given K. Oh, beautiful. Okay. So I just need to do the integral from -3 to 3, and then I think it's the square root of 1 plus f prime of x squared dx. I think that's it.
That looks correct.
Yeah? Okay, cool. Okay. And then, yeah, f of x is equal to 1 over 2k e to the kx plus e to the minus kx.
It'll be like incredibly easier if you write
If I write it
as
cosine.
trig,
Yeah. Okay.
or the hyperbolic cosine.
Okay. So I'm gonna say this is equal to 1 over 2k cosh of x.
Your 2's cancel. You keep your k, but cosh is defined as e to the u plus e to the negative u divided by 2.
Oh. Okay. Oh, nice. Okay. Yeah. Got you.
And there should also be a k in there as well.
Yeah. Cosh of kx. And then there, yeah, the 2 is gone. So it's just cosh of kx over k?
Yeah.
Cool. Yeah, and that comes from this. Okay. Yeah. This is the same thing as this. Beautiful. Okay. And then we need the derivative of that.
It's just sinh.
It's not negative?
No, that's why hyperbolic trig is really nice and easy. Is it's just cosh sinh, cosh sinh, cosh sinh. Because every time you derive it, the negative is just going to bring down a negative, and it's just going to keep flipping back and forth.
Oh, very cool. Okay, and then with the chain rule with the k, right? I have to pull the k out and the k cancels?
Yes.
What were you gonna say though? Sorry, Breskles, what's up?
I was just gonna say that it alternates with the negative signs on normal trig because there's an I in there, and when we bring in the I, I is what causes it to alternate.
Yeah, I goes from like I to -1 to negative I to +1 and then back.
Yeah, because there's you can relate the hyperbolic trig and normal trig through complex numbers.
Now here's
the
interesting question: is 1 plus sinh squared equal to cosh squared?
I believe so, or you can work it out, but I'm pretty sure it's sinh minus cosh is equal to 1, or it might be cosh minus sinh. But you have a very similar identity. That's why we call it hyperbolic trig.
Yeah.
Because instead of using a unit circle, we use a unit hyperbola instead.
Oh, very cool. Okay. 1 plus sinh squared is equal to cosh squared. Very cool. Okay. So then this right here is cosh squared of x, cosh squared of kx. And the square root of that's going to get rid of it. So now we're just left with -3 to 3 integral of cosh of kx dx. And is the integral of cosh sinh?
Mm-hmm.
Okay. But then there's a k. So then this is 1 over k sinh of kx from -3 to 3. So.
Yeah, and if you want to make your life easy, you could also write multiply by 2 and then from 0 to 3 because cosh is symmetric across your x equals 0.
I see. Because I'm gonna do -1 over k sinh of -3k, but then this will come out because I guess sinh is even, right? And so then just 2 over k sinh of 3k.
Mm-hmm.
Nice. Cool. Good question, Eagles. That was fun. Yeah, I know the hyperbolic functions are used a lot when predicting like a wire between 2 points and how much it droops.
Yeah, it's because the cosh curve minimizes the energy in the system.
The cosh curve minimizes the energy in the system. Okay, that's cool. Yeah, I remember something like that.
Yeah, minimizes the potential.
Like the gravitational potential, I guess.
Mm-hmm.
Very cool. Eagles. I think Eagles went to bed because it was super late for them, but. Cool question, Eagles. Alright, let's see what else we got. Come on up. Cuber. submitted so long ago. You've been waiting for almost over 3 hours, I guess. Well, I guess because you submitted an hour before the stream started. But all right, let's go choose a winner.
Let's go gambling!
Oh, that's nice, Nathan. They gave it to you for free. Google has been like putting out a lot of things to try to really incentivize. Wow, Tuma again.
Good job.
Okay, what's up? Ooh, here's another series.
3.5 hours ago. That's rough.
Yeah.
Ew.
I don't think Cuber's been waiting though. Cuber, are you still here? Cuber, you can say hi if you want.
If he's here, then he can take it.
Yeah, it's okay. Cuber. Okay. Cool. So there's a couple things happening here with this series that you have to kind of keep note of. First of all, this is alternating. Okay. And then I don't know what the fuck's going on here. N plus 7, x to the n.
No clue, mate.
No clue, mate. Fascinating. I think you want to compare this to another series, maybe. Well, okay. By the alternating series test, if you can show that something is alternating and it's also always getting smaller, like every term is decreasing, then you can prove that it's I think it converges absolutely. I think is Zach probably knows better than I do. Here, I'm gonna shout out Zach, you're the expert on the series game. I'll give you a shout out. I think we want to use alternating series test. Zach's rule: any polynomial in a series may be ignored. Oh, interesting. Any polynomial in a series. So wait, this we're just gonna ignore this. Excuse me. What? Oh, any polynomial of n. Oh, okay.
N plus 7.
Okay, I see. We can ignore this.
Wait, how come? Why?
According to Zach's rule.
Zach's rule.
Okay, so I think here's the reason. Let's say we were to write out some terms here, right? Let's just write some terms out, just so you can see. So this is going to become -1 to the 0 plus 1, so -1, and then this is times 7, and then this is going to be plus. Well, now this negative is going to go away because it's squared, and then this is going to be 9. 8 x to the 1, and then it's gonna be minus again when n equals 2, but that's gonna be -9 x squared, and then plus 10 x to the 3rd minus 11 x to the 4th. Do you see the pattern that's happening?
No. Is it going up by?
Do you see how the exponent's going up, and then also the
yeah,
coefficient in front of it is going up, but also it's alternating?
Yeah.
Okay. Zach says from the limit comparison, the limit as n goes to infinity of Pn plus 1 over P of n equals 1, as long as the degree of P of n is greater than or equal to 1. The degree of P of n is greater than or equal to 1. Oh, it's not equal to 0. You show by L'Hopital's rule. Okay. I see. So here, we're gonna consider what this would be. Let's just consider this term in the sequence, okay?
Yeah.
Okay. And then let's consider the limit as you go to the n plus 1 term divided by the nth term. Do you see how you're like seeing like how much does the next term compare to the term before it?
It's going up by 1.
Well, yeah, okay, so like in your series, right, you're adding, subtracting all this shit, right? This would represent like the nth term, and then this would represent the n plus 1 term. And so what you're trying to show is that the next term, how that compares to the term before it, like what's happening as we go all the way out to infinity.
Is there something invisible that you're showing me?
No. Can you see this?
Yeah, I see the dots and the is
Oh.
there like a polynomial?
No. Yeah, well, this would be the terms, right? Do you see how this is n equals 0? You see how this is n equals 1? This is n equals 2?
Yeah.
Okay. So we could consider all the way out to some random, I don't know, like n equals big N. And then the next term would be n is equal to big N plus 1.
Oh, yeah, right.
Okay. And so what Zach's saying is, like, let's take the limit as we look at the furthest term compared to the term right before it. So this is the furthest term, right? N plus 1. And then this is the term right before it. So
Yeah.
plugging that in, I would get negative 1 to the n plus 1. N plus 1 plus 1, right? Because now anywhere there's an n, I have to put an n plus 1.
That's right.
Okay. And then this would be n plus 8 x to the n plus 1 over negative 1 to the regular n plus 1 n plus 7
1 over
x,
that, you mean? Oh, wait, no,
x to the
never
n.
mind.
Yeah. We're dividing them, right? Yeah.
Yeah.
Okay. So now you can see a bunch of stuff starts to cancel, right? This is n plus 2. This is n plus 1. So the n's cancel, right? And all you're left with is just a 1.
Mm-hmm.
So, okay. And this is as n approaches infinity. So I'm going to have just negative 1 to the 1. N plus 8 over n plus 7. This 8 and this 7 don't really matter. Because if this is infinity plus 8, that's basically the same thing as infinity plus 7. Because 7, the difference between 8 and 7 is so small compared to what n is. So
I guess you just focus on the...
you just focus on this. So I think this is why Zach said that anything multiplying by n doesn't matter. Because at the end, this is insignificant. You can also think, whenever you did rational functions, let's say you did like x plus 8 over x plus 7, right? Do you remember like how you figured out the end behavior of this?
You gotta multiply the top and bottom by x.
You divide them by x. You divide, by 1 over x, right? Yeah, you divide by x, you divide by x, right? So this gets you x over x plus 8 over x plus 7 over x.
Yeah.
And suddenly you see as x goes to infinity, this goes away, and then this is just 1 over 1.
That's right.
Yeah. So that's basically what we're saying, is that, oh, okay, well, this is just going to go to 1.
Mm-hmm.
And then this, yeah, so it doesn't matter. And now this is just x to the 1.
Mm-hmm.
Yeah. So actually interesting, though. Limit as n goes to infinity. So the ratio between the terms, I see. Is negative 1, sorry. Well, negative 1 or 1, I guess. Doesn't really matter. It's going to alternate a lot. So, yeah, the ratio between between the furthest term and the term right before it is equal to x. And what do I need in order for this thing to converge? I need for the terms to keep getting smaller. Which means that the ratio between the n plus 1 term, so the far out term, and the one right before it, that ratio needs to be less than 1.
So we're technically just trying to get rid of all the n's and just like trying to find the ratio thingy?
Yeah. You could do the ratio test on this, actually. Yes. Yeah, you could do the ratio. So one way to do this is alternating series. Anytime you see something that's doing this negative alternating stuff, all you need to show is that that this is less than 1. Basically, you just need to show that that the terms are getting smaller. And I think actually this is the ratio test, Zach, right? This is literally doing the ratio test. This is the ratio test. This is just it's equal to x, and then you need the value of this to be less than 1. Yeah, just put an absolute value on it. Yeah, the ratio test is this.
Yeah.
Okay. Very cool.
So then now what? This is not like a normal. Yeah.
So now what the ratio test says is that the absolute value of x just needs to be less than 1. So that's your thing. I think it's just -1, 1.
Wait, how? Because I'm normally when I do these problems like with the tests and everything, I just get a value, and then I end up like seeing it, whether or not it converges or diverges. But now we're like doing like yeah, you know what I mean?
You got to check the endpoints for sure. So if you check, like, for instance, x equals 1, right? You'll see that these terms actually aren't getting smaller, right? You see how this would be 1 to the 1, 1 to the 2, 1 to 3, 1 to the 4? So then it's like -7, +8, -9, +10, -11. These terms are not getting smaller. And so in that case, in the infinity term is not going to 0. Based on what? Yeah, x is. So, yeah. So that's why the endpoints don't work. It has to be this. Also,
then,
because if this was equal to 1, then the ratio test says it's inconclusive.
How'd you get -1, 1? Like.
Oh, because the ratio test says that the absolute value of this has to be less than 1.
Yeah.
And so the absolute value of all of this just became equal to the absolute value of x.
Yeah.
And then so the absolute value of x has to be less than 1.
Oh, what? It's just
so that-
x.
So then that's this.
It's what the heck? That's
The
weird.
the absolute value of x has to be less than 1, right? So if it was -1/2, that becomes +1/2. +1/2 is still less than 1. If it's -0.9, that becomes +0.9. 0.9 is still less than 1.
Huh.
Yeah.
Because
there's
I know
actually there's 2 ways to solve it, but
yeah, I'm just not used to it like being like a variable.
yeah, you're whenever you've been like proving convergence or divergence, you don't have x. Like it's not a free variable. So
That's
you're doing the convergence and divergence tests that you usually do for series, but you're holding x as something you can vary later. And so at the end, you'll get down to this, oh, well, it would converge if the result of the ratio test was less than 1, but the result of the ratio test depends on what is x. And here you're like, oh, well, x needs to be less than 1 then.
Isn't it like -1 though? Because look, the -1 multiplying. I mean -x. I mean, the negative
Okay,
x.
yeah,
is
no,
multiplying.
because look, so the absolute value of -1 to the 1, that just kills off the negative, right?
What if
So
you
you
get
just
like
have-
x squared or something?
Then yeah, I don't know. X squared would have to be less than 1, but square root of 1 is still just 1. You could have gotten this. You could have gotten this. You could have gotten like 2x is less than 1, okay? And then x would have to be between -1/2 and 1/2.
Right.
Okay? And this is they will also call this the radius of convergence. You'll say the radius of convergence is equal to 1, and you could say it's centered at x equals 0. Because if you think about it on like a number line, if this is x equals 0, you're saying it converges for out to -1 to the left and out to +1 on the right. So, I don't know. It's not really a circle because there's nothing in the y-axis, but this is considered like the radius of convergence. Because sometimes you'll be centered somewhere else. So, for instance, I don't know how this would happen, but you could get like absolute value of x plus 3 is less than 1.
Yeah.
And then in that case, right, it's, x plus 3 is less than 1, or x plus 3 is less than -1. So you get like x is less than -2, or x is less than -4. How does that work? Something like that. So it's in between -2 and -4.
Mhm.
Yeah.
Okay. Can you do my other one since the other dude's in here?
Yeah. It would become a series if you do the Laurent series. Okay, maybe it would be. Okay, here. Let's see. Yeah, x for x minus 5, yeah. Okay.
Yeah, because then it would be in the complex plane, have the absolute value, but it'd be complex. So it's a circle.
All right. Let's...
I just put it in the chat since it's easier.
Okay, cool. All right, let me just put the solution for this one. Okay. Oh, okay. Yeah, this is another ratio test. Yeah, anytime you see like this stuff happening, like power, or maybe this is a root test. This could be a root test. But I think this is a ratio test. Anytime I see factorials, I instantly think ratio test.
Yeah, right.
Because this would be 5x to the n plus 1 over 2n plus 2 factorial, then times 2n factorial over 5x to the n. Right? Because if I'm dividing, I just multiply by the reciprocal.
2n plus 2.
So then, I mean, this will cancel with this. You can rewrite this as 2n plus 2 times 2n plus 1 times 2n factorial. For this part, you can rewrite it this way. So then this is 5x.
Oh, right, yeah.
And then
the negative ones give me as well.
Negative one? Sorry, what? Why is there's no negative one? What?
Like when you do factorials, and you get like a negative one, like x. You know what I mean? Like when you have negative those ones are weird.
I don't think you'll ever have negative factorials. What are negative factorials? I've never seen those.
It's like when it goes
gamma function.
Gamma functions. Okay.
Yeah,
well, okay. Watch. So this goes away. This goes away. As long as x doesn't equal 0. And so then you're. Yeah, and this is as n approaches infinity. So then this is 1 over, I don't know, like 4n squared, basically. Which as n goes to infinity is equal to 0. So then this converges. And I would say this converges for all x as long as x doesn't equal 0.
Oh. Wait, scroll down. 1 over 4n squared. This is different. There's no x this time.
Yeah, because the x is canceled out. Because you had 5x to the n. You had 5x to the n plus 1 over 5x to the n. One sec. Let me make sure I did this right. Yeah. Oh, sorry, there's a 5x left. Sorry, there's a 5x on the top. Sorry, I'm dumb. I fucked up. Sorry. I didn't cancel my.
I was like, that's way too easy.
Yeah. Okay. It's this. There we go. But this also converges. It also converges for all x. Because you're still gonna have n squared on the bottom.
Because it's bigger.
Yeah. And actually, so yeah, I was wrong when I said it. When x doesn't equal 0, I was assuming that this one was still there. But it's not, because you cancel it out. It's no longer there. So I would say converges everywhere. So technically you'd say like negative infinity, comma infinity. Yeah.
Wait, how'd you? Oh man, because the 4n. Because you get negative infinity, you get infinity. Oh god, this is so confusing, bro. I hate this.
No. Okay, look. When you're doing the ratio test, right? You do the n plus 1 divided by the n. So that's the same thing as multiplying by the reciprocal of it having n in it.
Right.
Okay. Then you start doing some cancellations, right? So 5x to the n cancels out with 5x to the n here, but there's still a 5x to the 1 left. Yeah. 2n factorial cancels with 2n factorial, but there's still this left. And then I cheated a little bit here. I only considered the leading terms in n. So I said I don't fucking care about this.
Disqualified.
Right?
Yeah.
So the leading terms in n become 4n squared. And then for the ratio test, we're taking the limit as n goes to infinity. And if this is infinity on the bottom, I don't care what this is. It will always converge.
Huh. Okay.
Yeah.
That makes it a little too easy.
The other way to see here is that, so in general, factorials are like the king of like big things. I think, what is it? It's like x factorial beats out like x to the x, which beats out a to the x, which beats out x to the a, which beats out, I don't know, ax, which I think beats out like ln of x. Oh, x to the x does beat out x factorial? Oh, take that back. We have a new challenger. Okay. Yeah, you rarely see x to the x though. Okay, there you go. X to the x is the king. So anything factorial will beat out some, like, in this case x is a constant to the power.
Right.
Yeah. Yeah. Okay, you're right. Yeah, 3 times 3 times 3 beats out 3 times 1. Yeah. Yeah. So just even by looking at it by inspection, factorial beats out exponents, and so it doesn't fucking matter what x is. Unless x was n.
Oh no.
If x was n, this would be a different story. But x can't equal n. X has to equal a constant number. The hard part is remembering. Yeah. So this is the other thing. And again, I did a little bit of a shortcut here. When you plug in n plus 1 into here, it's 2 times n plus 1 factorial. And that's why that gets you 2n plus 2.
Oh, right, yeah. I knew that, but in the beginning I always thought it was like 2n plus 1.
It's not 2n plus 1 factorial, it's 2n plus 2.
Yeah.
It would still converge anyways, but yeah.
That part isn't bad, actually. Like, the whole simplifying and, like, the setting it up, I feel like I could do that. But, so on the bottom, it converges, right? And then you get... I'm still confused how you got negative infinity to infinity. Because
it doesn't matter what x is. This will always be equal to 0. So x can be anything.
0, right.
Well, so the limit as n and the limit as n goes to infinity of the ratio test does not depend on x anymore. Here, when we did the limit as n goes to infinity of the ratio test, we got x. Like, x survived.
Right.
Okay? Because it was just -1 to the 1, 1, x to the 1. So x survived, and I had to show that that was less than 1. Here, this n squared on the bottom will obliterate anything on top. So I don't care what this is, because this limit will always go to 0.
Okay.
And
so
it means x can be whatever.
And if it helps, since we're considering the 5x as a constant, right, and 4 is a constant as well, you could actually move that 5 over 4x outside of the limit and then evaluate the limit of 1 over n squared, which that limit is 0. So when you multiply 0 by that 5 over 4 x to the n, you can move the x out as well, too.
Oh, you can move the x out as well. Oh, yeah, because x is a constant.
Yeah, because it's constant, and we're just evaluating the limit with respect to n.
Right.
Right? So we know that becomes 0, and anything multiplied by 0 is 0.
Yeah.
So no matter what value of x we have, we're multiplying by 0, it works.
Yeah.
And that's okay.
Huh.
I like that. That's more rigorous. Yeah. Yeah, because this limit as n goes to infinity only cares about n. X is set as some value, so we could always take that out.
So you're saying it's negative infinity to infinity because I can use any value.
Good. You can use any value for x. Yeah.
Huh.
Yeah. This is the catch-all for, like, just fucking anything.
Right.
Yeah.
Oh my god, there's so many. There's like 12 more problems.
You'll get through. Are they due tomorrow?
No, they're due next week. But I mean.
Oh, good. You're getting a head start.
Yeah,
on
it's
it,
not. Yeah, that's right.
Yeah. Good. Okay. Cool. I'll put this one in the. Well, wait. What? Was this question 2 you had submitted? Wait, 1 second. Let me just see. Sorry. Just so you have, like, the link for it as well. Yeah. Okay. It was question 2. Okay. So let me mark question 2 is done.
Yeah. But I want the screenshot.
I'm gonna get you the screenshot. Cause watch.
Yeah.
Cause now it's gonna show up. Oh no! It posted Cuber's question. Fuck. Wait, what? No, I told you to. Okay. Post that one maybe. Let me see if it did it. There you go. There's your question. And so then I'll put the screenshot in.
Oh, bet.
Yeah, you also get a link to the YouTube of like when we did. Oh wait, no, I need this one. Sorry. Okay.
You like clip the thing? No way.
Yeah. So after this stream ends, you can click here on this YouTube link, and it'll go to the recording, and it'll also go to the timestamp of like when we worked on this question.
Dude, that is so goated.
ChatGPT vibe code.
That's dope.
Zach's like.
Oh shit, not good.
Anyways, okay, cool.
Wait,
All right.
where is it?
It's in the homework help threads. You'll see your name on a couple things. All right, let's see. I technically should go, but Samsy, what do you got for me? Oh, is this a different person? Oh. Well, let me just do this one real quick. This is another. We're doing a lot of series today. Here, I'll do Samsy's real quick. Is that you, Machka? Or are you Samsy?
It is that time in Calc 2.
It is that time in Calc 2, yeah. We're just doing sequences and series all day. Okay. Determine whether the series. So this has no x's in it. We're just determining whether it's convergent or not. If it is convergent, find its sum. Okay. I feel like you need to combine this into a single denominator, right? Because
No. You could do it.
or I
as
could just
two
say this shit is
separate
just zero.
series.
Or you just say this shit is zero.
Well, you can, if they're both convergent, you can just evaluate each term. Because the sum of two convergent series is going to be convergent, and if one of them's divergent, others are diverge.
Okay. The first one is geometric. Yeah, I got you. Okay. So yeah, let's break this up into two series. All right. So this is.
Dr. Gold.
What's up, brother?
You know when you clip the thing, it takes you to the end of like the clip. It doesn't take you to the beginning.
No.
Yeah, I
it
was
take-
gonna say I noticed that, but you gotta
yeah.
go back.
It takes you to like somewhere close to the end. It's not to
Yeah.
the exact time. So it takes you to I think a minute before I mark the question done.
Yeah.
Right? Because otherwise it would be kind of crazy for it to somehow detect when we started on the question.
Okay. I was just gonna mention that.
Oh no, I appreciate that. Yeah. It's yeah. You'll see it. Okay. This is 5 times this, right? And then plus 3 times, and then this is 1 over n plus 1. Okay. This is a geometric series, right? So this is geometric, where it's 1 over e to the n is r to the n. So I think the sum there is just equal to 1 over e. No, I think it's just equal to 1 over 1 minus 1 over e for a geometric series. And then it's 5 times that. So it's not quite. I know, I think technically I also have to start at n equals 0. Oh, you're talking about this one. This one. It's 1 over e divided by 1 minus 1 over e. Is it? Numerator is the first term. Oh, okay, cool. Oh, yeah. The sum is equal to, it's a naught over 1 minus r, right? Yeah, okay. So that's going to be 5 over e minus 1 for the first part, right? Because e's going to go on the bottom. And then this, yeah, you can do partial fractions. So partial fractions. Or you can just remember this one, because it comes up a lot. And that's going to be 1 over n minus 1 over n plus 1. And then, yeah, this is telescoping. Because write out some terms, right? So for n equals 1, you get 1 over 1 minus 1 over 2. And then for n equals 2, you get 1 over 2. So this is plus 1 over 2 minus 1 over 3. And then for n equals 3, you're going to get plus 1 over 3 minus 1 over 4. Yeah, and these all telescope. Super cool. This cancels with that. That cancels with that. This will cancel with the next one. And so this is all that's left. Okay, cool. So then you get plus 3 times 1. So yeah, I guess that's 5 plus 3e minus 3 over e minus 1. 2 plus 3e over e minus 1. I think so. Here's my answer. Okay, cool.
Oh, yeah.
Nice, AMC. Let's mark that one as done. And then I think we did everything. Wow. Good job, everybody. Okay, cool. Let's close the stream. Thank you everyone for coming to Actual Education Office Hours. Appreciate all you guys. Great questions today. Fun stuff we worked on. I appreciate all the learning. Appreciate you, Zach. I 100%ed the stream. Yeah, we went through all the questions. So that was pretty dope.
That's dope.
Minus the ones I couldn't do. It's okay. Some of the double E ones, I apologize, JH. I just don't know about op amps. But the questions still get always added to our Discord. So if one of y'all watching knows about op amps and more electrical engineering than I do, please feel free to go through and give your input into how you would solve them. But great. All right. So our next stream is going to be tomorrow. If you ever want to figure out when we're streaming, go to actualofficehours.com. Streaming schedule will show you all the different times. So it looks like MathPon's got a stream tomorrow morning. Zach's doing some math tasks. And then we'll be streaming at 6 o'clock. And then Penn Center's Destroying AI. I don't know what that means.
Oh, no.
Sounds fun, though.
That's dope.
So go check that out. Also, while you're there, make sure to go watch us live on Twitch. Go join our Discord. It's where we announce all the fun stuff we're doing. Including, we're going to have a trivia game on Saturday with Zach, E2iPi, called 16. I'm going to be hosting. So we'll make an announcement in the server about that later. Once you have the... I think we got a time settled, right? I think it's 2:30 my time. But once you have the poster or the advertisement. Nice. Wow, and we got a raid. What's up, guys? With a party of 12. That's awesome. What type of trivia? So we're going to be doing a lot of like math trivia on Saturday. Thanks, RW Rob, for the raid. Welcome, Raiders. Yeah, so Saturday. So if you check the streaming schedule here, Zach, Zach, have you put it in yet? But Zach will put it in the schedule for a math trivia game. Yeah, it's gonna be super fun. It's originally around like Pi Day stuff, but we're gonna be doing some other types of trivia questions. 3:30 Mountain. Okay, so that will be 2:30 Pacific. Yes, so come on by. Appreciate the raid, Rob. I was about to stop streaming, but for those that are watching, just so you get a little idea of like what we do. We're a nonprofit. We help kids out with like math and science questions, and people submit questions. We were doing some infinite series today, like convergence stuff. We also had some catenaries. We had some chemistry we were doing. Some Weierstrass substitution, some graphing, basic things. All sorts of fun questions. But in the future, make sure you're following. And this is the website we use for people to upload screenshots of their questions they need help with. And then also you can see the schedule of when we stream. So we're a little bit over time, but I wanted to make sure I finished everyone's questions today. So tomorrow we'll be on as well. So come on by. That being said, we're gonna go. If you were coming here for math, you're in luck because we're gonna go say hi to another awesome math streamer. His name is Justin. He's a professor, and he's gonna be doing some Monday night math with some calculus and stuff. So let's go find his. I think I'm following him somewhere. Where is he? Nice. Okay, we're gonna go say hi to Justin. He's doing something with, I think, Fourier series. It looks like he's taking a 3-minute break, but go say hi to him. We'll have fun. Awesome. Okay, cool. Have a wonderful rest of your Monday. We will see you tomorrow, Tuesday. Peace. Don't forget to close the stream. Yes.
Girls, your hot chicks meals.
Bobby! Shh. Okay, coast is clear. Gimme. Grab your milkshake.